Alright guys, today we are starting a new chapter, and this happens to be my favorite chapter in all of pre-cal, and it is a chapter on trig proofs and identities and simplifying trig functions and whatnot. So we're going to just jump in, and what I want you to do in this video is I want you to pause the video and I want you to try to fill out all of this information before you look at what I'm doing and see if you are able to follow along and see if you get the same thing that I get, okay? So right now I'm going to ask you to pause the video, and I want to ask you to fill in these reciprocal identities, and number one, this should be a review for you. Alright, sine is going to be, as we know, it's going to be, well, let's start with cosecant, and maybe that'll be easier. Cosecant is going to be 1 over the sine of theta. And then secant is going to be 1 over the cosine of theta. Cotangent is going to be 1 over tangent of theta. And tangent of theta is going to be 1 over cotangent of theta. And then cosine is going to be 1 over secant of theta. And sine is going to be 1 over cosecant of theta. Alright, so we know all of those different relationships. Okay? Now, problem number 2. When you find tangent on the unit circle, you are finding opposite over adjacent, which happens to be y over x. When you find cotangent, it's going to be x over y. Alright? So when you find sine on the unit circle, you're finding the y value. When you find cosine, you are finding x. So what is the tangent in terms of sines and cosine? Well, this is still a review. So I want you to pause it and fill in tangent and cotangent. Alright. Tangent is simply going to be sine of theta over cosine of theta. Cotangent of theta is going to be cosine of theta over sine of theta. The way I remember cotangent is cosine is on the top, so maybe we'll underline that. Cosine is on the top, and cotangent starts with co as well. So that's how you can kind of remember which is which. Alright? So, problem number 3. Using, and by the way, this is all leading you somewhere and helping to help you discover some relationships on your own. But a lot of this is not going to make sense right now until you get to the second side of this paper here. Alright, using the Pythagorean theorem, write an equation to express the square of the length of the radius in terms of x and y. Alright, so once again, you have this point on the curve, and we'll call that point xy. Well, it's already there, so we don't need to put that there. So that means from the origin that this distance is x, and that distance is y. So we know that the unit circle has a radius of 1, right? We know that because that angle is 0 degrees and it has coordinates of 1, 0. This is 90, it has coordinates of 0, 1, and so on. So we know that the radius of the unit circle is 1. So in terms of x and y, I want you to write down just a simple equation that relates x and y using the Pythagorean theorem, alright, and this triangle. So I want you to do that. Pause the video and do that now. Alright, and you should have simply x squared plus y squared equals 1 squared, which is 1. Alright, that's pretty basic. Alright, so in the next blank, it says to use the relationship between x and y and the sine and cosine values of theta to rewrite your equation in terms of sine of theta and cosine of theta. So I want you to think about what does the x-coordinate on the unit circle represent? What function does the x-coordinate represent? All right. What does the y-coordinate on the unit circle represent? And so then I want you to replace x and y in the Pythagorean theorem equation with those values, with those functions. So instead of writing x and y, I want you to write the trig functions that those are related to. Pause the video. All right. X, we know, on the unit circle is the cosine value, right? We've been talking about that. And y is simply your sine value. So, if that is true, then x squared is simply going to be cosine squared of theta plus y squared, which is simply sine squared of theta, equals 1. That, my friends, is extremely important. Extremely important. I'm going to put stars all around that. If you don't remember anything, I want you to remember that. Okay? Cosine squared plus sine squared equals 1. Alright, so that is going to be the first important Pythagorean identity. We call it that because we used the Pythagorean theorem to generate that. And that's going to be your first important theorem, not theorem, but identity or relationship that you need to have memorized. All right? So we're going to prove this by choosing any angle from the unit circle, and we're going to plug it in. So let's just say we are going to choose, why don't we let theta equal 30 degrees? Theta equals 30 degrees. Okay, so what is the sine of 30? Well, that would be 1/2, right? And what would the cosine of 30 be? Well, the cosine of 30, either you can draw a triangle or you can use your unit circle. It's going to be root 3 over 2. Sorry for bunching everything together. And let me erase that to give me more space. Alright, so now we're going to prove that this works for any angle. So cosine squared of theta, which means we take the cosine value, root 3 over 2, and square it, plus the sine, which is 1/2, and square that. This should equal 1. Well, let's see. When you square root 3, you just get 3. Okay, so that's going to be 3. When you square 2, which is the denominator of this fraction, you get 4. Alright, plus squaring 1/2, you get 1/4. Well, 3/4 plus 1/4 is 1 all day long. So it works for any angle you choose. Alright, and we're on the second page now, number 6. Now, it says solve the answer to number 4 for cosine squared. So what we're going to do here is, so that we don't have to flip back and forth to the front side of our notes, we are just simply going to write down what we were able to prove. Cosine squared plus sine squared equals 1. Alright, now what it wants you to do for number 6 is it wants you to solve that equation for cosine squared. In other words, get cosine squared by itself with nothing else on the side other than cosine squared. You should be able to do that, and I'm going to give you a chance to do it. So I want you to pause the video and go ahead and solve for cosine squared. And go ahead and do the same thing for 7 as well. Take the same equation, cosine squared plus sine squared equals 1, and solve it for sine squared, meaning isolate sine squared of theta so that it's the only thing on that side of the equal sign. Should be pretty simple, one-step process. Alright, you should have gotten cosine squared equals 1 minus sine squared. And then sine squared is 1 minus cosine squared of theta. All right? Now, number 8. All right, so far, there should be 3 things that you should begin to memorize. Number 1, right here. Number 2, right here. Number 3, right there. Okay, you will see why towards the end of this video, and you'll start to understand. Okay, number 8, use your same answer to number 4, which is the cosine squared plus sine squared equals 1. And it says divide through by cosine squared and simplify your answer. Excuse me. So what it wants you to do there, just so you can have clear direction, it wants you to take we'll call this equation number 1. Okay, we'll call that equation number 1. Take equation number 1 and divide each term by cosine squared and rewrite that particular equation, okay, without using sines and cosines. So use other trig functions, and you're going to discover something, you're going to discover yet another Pythagorean identity. So pause the video and divide all of equation 1, all 3 terms, by cosine squared. And go ahead and do the same thing for part B. Divide everything by sine squared and see what you come up with. All right, let's see what we get here. We're going to start with cosine squared plus sine squared equals 1. And we are going to divide everything by cosine squared, divide by cosine squared, divide by cosine squared. All right, let's see what we get. Well, cosine squared over cosine squared is just 1. Bingo. Sine squared over cosine squared, well, what's sine over cosine? We said that on the front page, that's tangent. So what do you think sine squared over cosine squared is? Hey, that's tangent squared. There it is. All right, what do you think 1 over cosine squared is? Well, if you look back on your first page, 1 over cosine is secant, so 1 over cosine squared is, you guessed it, secant squared. All right, and maybe we'll call that equation 4. All right, so now we're going to do the same thing, but we're going to divide this time all the way through by sine squared. So that's going to start, let's start with cosine squared. This is our base equation, plus sine squared equals 1. And we're going to divide everything by sine squared. So divide by sine squared, divide by sine squared, divide by sine squared. All right, let's see what we get. Well, cosine squared over sine squared, you guessed it, cosine over sine is cotangent, so cosine squared over sine squared must be cotangent squared. And then sine squared over sine squared, hey, anything divided by itself is just 1. And then 1 over sine squared, yep, you guessed it, guys, you're getting it, cosecant squared of theta. All right, we're going to call that maybe equation number 5. All right, now 9 and 10, I think you know what you need to do. It says solve the answer to 8a for tangent squared. All right, you should be able to do that. It's the same example, same process as 6 and 7. Number 10, solve the equation from 8b for cotangent squared, and I want you to put the result in the box. So pause the video and go ahead and solve for tangent squared and cotangent squared. All right, tangent squared is going to be equal to secant squared of theta minus 1. You say, Mr. Parr, how did you get that? Well, I took equation number 4 and I simply subtracted 1 from both sides. Hey, that's not that hard. And then cotangent squared. Same thing. I'm just going to subtract 1 from both sides, and I get cosecant squared of theta minus 1. So maybe we'll call this equation 6 and equation 7. All right? Now, we've got a whole bunch of different formulas that we can use now, and now we're going to apply them to problems in example 11. All right? And this is really what we want to get to. So we are going to be asked to simplify several examples, starting with example 11a. Now let me help you a little bit here. When we ask you to simplify, basically that means that you need to get this down to either so simplify, let's write it down. Simplify means you need to get it down to either a number, a single number most of the time, or, that's a little ugly. Let's just make it a little nicer. A single number or a single trig function. So in other words, after you get done simplifying, that's what you should have left. Now, let me caution you on something, all right? This unit is heavy on being able to add, subtract, multiply, and divide fractions. So if you have never been good at fractions, you are going to be great at it after this unit, because we're going to be doing a lot of that. Okay? So number 11, here's what I want you to do. I want you to rewrite tangent of theta and secant of theta. I want you to rewrite those in terms of sine and cosine, and then I want you to divide the fractions, and I want you to see what cancels, and I want you to write down what it simplifies to. Go ahead and pause the video and do that now. All right, tangent, we know, is sine of theta over cosine of theta. And what is secant? Secant is 1 over cosine of theta. So what are we doing? We are dividing a fraction by another fraction. So we learned a long time ago that anytime you're dividing fractions, you keep the top fraction and you change to multiplication and you flip the bottom fraction and you multiply. All right, what happens? Cosines cancel, and what are we left with? Sine of theta. Did we get it down to one trig function? Yes, we did. All right, we are done with example A. That is as far as you can go. All right, guys, I am jumping around because I'm trying to pick the problems of least difficulty first. So just to kind of get you warmed up and get you comfortable with the process. So I'm going to go ahead and jump down to letter D. And I want you to see if you can simplify this. And I want you to, first and foremost, see if you can remember what that is equal to. I want you to look on your page, and I want you to see if you can find what 1 minus sine squared is equal to. And then I want you to simplify this, okay? So pause the video, see if you can simplify this. All right, 1 minus sine squared is going to be from, I believe it's either equation 2 or 3, I think it's 2. 1 minus sine squared is equal to cosine squared. So the numerator becomes cosine squared of x. The denominator is cosine of x. Well, the numerator, cosine squared of x, okay, this is kind of just showing all the steps, but that's just going to be cosine of x times cosine of x. When you square something, that means multiply it by itself. And then you're dividing by cosine of x. So one of the cosines cancel, leaving you with cosine of x. And that is the answer. All right, letter E is just as simple. Secant of theta over cosecant of theta. So, what do you think you need to do here? You need to change both of those trig functions into sines and cosines and divide the fraction. So I want you to do that now. and see if you get the same answer I do. So pause the video. Alright, secant of theta is 1 over cosine of theta. And cosecant is 1 over sine of theta. Alright, we're back to dividing fractions again. 1 over cosine of theta. Keep the top fraction. Change to multiplication. Flip the bottom. And we get sine of theta over cosine of theta. You say, well, I'm done. No, you're not. Because remember, simplifying means you need to get it down to a single trig function. So sine over theta we recognize to be tangent of theta. Now we are done because we've got it down to one trig function. Alright, letter F. Once again, not very difficult. I want you to think about what cotangent is equal to. And then I want you to think about what cotangent squared is equal to. Same thing with secant squared. And see if you can simplify. Looks like you're multiplying fractions this time, so this shouldn't be too bad. Go ahead and pause the video and see if you get the same thing that I am going to get here in just a moment. Alright, let's see what we get. Cotangent squared is equal to cosine squared of theta over sine squared of theta times secant squared, which is 1 over cosine squared of theta. Hey, look at that. Convenient. Alright, now let me point out something very important to you. You can only cancel factors when you are multiplying, not when you're adding. So, whatever you do, please don't ever do this. Alright? Please don't do that, because you can't cancel factors when you're adding two things together, only when you are multiplying. Alright, so let's go back to our problem. Cosine squared over cosine squared cancels out, and that leaves us with 1 over sine squared. Well, that is, if you really want to multiply it all the way out, that's 1 over sine times 1 over sine. Oops, that looks ugly. Alright, 1 over sine times 1 over sine. Alright, because when you multiply fractions, you multiply straight across the top and straight across the bottom, right? So, 1 over sine, oh, that's cosecant. And 1 over sine, oh, that's cosecant. So, cosecant times cosecant is cosecant squared of theta. You are done. Alright, I saved the last two for last because, in my opinion, they are the most challenging. And so, let's see if we can do letter B. Sine of theta plus cotangent of theta times cosine of theta. Now, a lot of these problems are just going to take practice. It's just going to take a lot of practice, guys. That's what it's going to take. And I have a lot of practice for you. So, sine of theta plus cotangent of theta. Okay, cotangent we're going to write as cosine of theta over sine of theta. Now, some of this is going to be trial and error for you, so don't get discouraged. Alright? Times cosine of theta. Well, I'm just going to write that as cosine of theta over 1. Make sure that you write things that don't have a denominator. Just write it over 1. That's going to help you a lot. So, we are going to multiply these two fractions together, and we are going to get sine of theta plus cosine squared of theta over sine of theta. And I'll put that over 1. Alright, so you may say, well, Mr. Pratt, I don't even know where to go from here. I'm so confused. Well, pay attention to this. What are you doing with these fractions? I'm adding them. You're right. You're adding them. So what has to be true? What do you have to have in order to add fractions? Yep, you guessed it. You got to have a common denominator between the fractions. So how am I going to get this denominator to match that one? I need to multiply top and bottom by sine of theta. So I'm going to multiply top and bottom by sine of theta. Top and bottom. Okay. Do I need to multiply this fraction by anything? No, because it already has sine of theta. So what do I get? I get sine squared of theta plus cosine squared of theta divided by the common denominator of sine of theta. Now you say, Mr. Parr, I'm still confused, don't know where to go, don't know what to do. Well, hey, guess what? I want you to take a look at equation number 1 that you solved for on the front page of your notes. And what is sine squared plus cosine squared? After practice, your eyes will start to recognize that immediately, and you will say, oh, that's just 1. Okay, I'm on to something. That's 1 over sine of theta. Oh, that's cosecant. Look how beautiful that is. Came out as cosecant of theta. And you're done with this problem. Alright guys, I think you can see how easy G is. Cotangent of theta over cosecant of theta. This is pretty basic. Cotangent of theta is similar to one we had earlier. That's your cosine of theta over your sine of theta. Divided by cosecant, which is 1 over sine of theta. I'm dividing fractions again. So I'm going to keep the top fraction. I'm going to multiply by the flip of the bottom. And of course, the sine thetas are going to cancel. And I am going to be left with cosine of theta. Yep, it's that easy. Alright, letter H. Getting a little more difficult here. Alright, so secant of x minus sine of x tangent of x. Alright, see what we got here. Secant is 1 over cosine. Okay? Now, just to let you know, there are lots of different ways of simplifying. It's not always, well, I'm just going to change everything to sines and cosines. With practice, you'll see that sometimes that's the best method, sometimes it's not. 1 over cosine minus sine of x. I'm going to go ahead and write that as over 1. And then tangent is sine of x over cosine of x. Alright, so now I'm going to multiply those two fractions together, and I get 1 over cosine of x minus sine squared of x over cosine of x. Okay, do we have a common denominator? Yes. You say, why do we need that? Well, because we're adding and subtracting fractions. So anytime you're adding or subtracting fractions, you have a common denominator. You have to have a common denominator. So I'm going to combine my numerators. And I'm going to put that over the denominator, cosine of x. Okay, do your eyes recognize something? Bingo. 1 minus sine squared. That's something special. That's cosine squared over cosine of x. Well, we did this one earlier. One of the cosines on the top are going to cancel with one of the cosines on the bottom. So maybe we'll write it like that. And that's going to leave us with cosine of x. Easy. Alright, letter C, and the very last example that we're going to go over. I really don't expect you right now to know exactly how to do these. So I'm just going to kind of try to work it out and see if you can kind of follow along. Alright, you may be tempted to change secant squared into 1 over cosine squared. Yes, it is 1 over cosine squared, but there is an easier way to do this problem. So I'm not going to change secant squared into 1 over cosine squared. I'm going to leave secant squared alone. And I'm going to say, cosine squared, sine squared. Isn't there something special about cosine squared and sine squared? Well, you say, Mr. Parr, but they're both negative. Hey, can't we take care of that by factoring out a negative 1? All right, if we factor out a negative 1, then what do we get? Cosine squared plus sine squared. Ooh. What is cosine squared plus sine squared? Well, it's about third or fourth time we said it on this video. That's 1. So 1 times 1 is 1. So what do we get? We get secant squared of x minus 1. And earlier we proved that that is equal to tangent squared of x. And that is one of the equations in your boxes above on your notes. Alright guys, last example that you need to do for this activity. This one takes a little time. You can see it's complicated. Now, it's not going to be that bad if you know how to add fractions and divide fractions. That's it. That's the main skills you need to know. So let's go ahead and work this out. Cosecant is going to be 1 over sine of x plus cotangent, cosine of x over sine of x minus sine of x over 1. Okay, all of that is divided by cosecant of x plus cotangent of x. Cosecant, once again, is 1 over sine of x. Cotangent is cosine of x. Oops. Cosine of x over sine of x. All right. Now, there's different ways you could go about this. What I am going to do, I am going to multiply the entire top fraction by sine of x. And I'm going to multiply the bottom by sine of x. Okay? So, that means I need to do some distributing. I distribute it here, distribute it there, distribute it there. I need to distribute it here, I need to distribute it there. Okay, when I take the sine of x, I'm looking at the top, and I multiply it times this guy, what do you think cancels? Sine of x. So what am I left with? I'm left with 1. When I multiply sine of x times cosine of x over sine, I get cosine. And then when I multiply it times sine of x, I simply get negative sine squared of x. And then on the bottom, if I multiply sine through, I get 1. And then I also multiply it, and the signs will cancel, and I get cosine. Now, let me caution you, whatever you do here, please don't do this. I know your eyes want to. Don't do that, okay? You don't want to do that. So let me erase that, and because that's what we don't want to do, okay? Can't do that because it's not factors. So let me go ahead and write what we had here. 1 plus cosine of x and 1 plus cosine of x. Okay, do you see this? 1 minus sine squared. You say, Mr. Parr, there's a cosine in the middle of that. You can't just do that. Well, yes, you can. Is 2 plus 3 plus 4 the same as 4 plus 2 plus 3, the same as 3 plus 4 plus 2? Yeah, it doesn't matter what order you add and subtract things in. So 1 minus sine squared is cosine squared. And we already have another cosine on the top. And on the bottom we have 1 plus cosine. Alright? Now, what can you factor out of the top? They both have a cosine of x common to them. So, I'm going to actually finish this over here. Alright? Finish this over here. So I'm going to factor out a cosine of x from the top, and I get cosine of x plus 1. And on the bottom, I have a 1 plus cosine of x. Okay, now I can cancel that with that. You say, well, I thought you said you couldn't do that. Well, you can when you're multiplying, right? When you're multiplying, you can cancel factors. So what's my final answer? Cosine of x after all of that work. All right, guys, tomorrow in class, we're going to practice all of this. See you tomorrow.